Hi, in today's lesson we're going to be looking at how to work out the area underneath the curve and the area between two curves. Now the process is by using integration. Alright, so here what we have is a curve on the xy axis. So this curve here is some function of x. The area bounded between the curve, the x-axis, and the line x equals a and x equals b is this shaded region here. The area, or the shaded area, is given as the integration of the function f of x with respect to x between x equals to a and x equals to b. So you would have seen this in your first year of your AS level maths. Is basically this is the formula for working out the area between a curve and the x-axis. In the first example, we have a curve given by the equation y equals to 9 over the root of 4 plus 3x. And the diagram describes a region R, which is bounded by the curve, the x-axis, and the line x equals 0 and x equals 4. So this is the bounded region R, and we're asked to find the area of this region R. We know that the area underneath the curve is given by the formula, the integration of the function with respect to x, and the x value is from 0 to 4. So this is basically the integration of 9 over the square root of 4 plus 3x, and when we perform this integration it will give us the answer. This is the same as, so first step is to get it into the form ready for integration. So that's 9 bracket, we're basically bringing the denominator to the top and writing as a power of a bracket. So 4 plus 3x to the power of minus a half with respect to x. Now, what kind of integration is this? Well, if we look at the function inside the bracket, if you differentiate the function inside the bracket, we get a multiple of that on the outside. If we differentiate what's inside, we get 3, and we have a multiple of 3 sitting on the outside. So well, that told us that it's the reverse of the chain rule. What we do is we try the same bracket as 4 plus 3x, and we do try it with the power of 1 more. So 1 more, one added on to minus a half gives you a power of a half. Now, this has to differentiate back into that. So if we try differentiating this, what we get is a half bracket 4 plus 3x to the power of minus a half times by 3. This in effect is 3 over 2. We don't need cancel off the 3 over 2 by multiplying by 2 over 3, followed by we need a 9, so times by 9. So altogether our multiplying factor is 6, and therefore we are now integrating. So let's do it here. So we substitute the upper limit into the expression, so we get 6 bracket 4 plus 3 times 4 is 12 to the power of a half. Subtract 6 bracket 4 plus 0 close bracket to the power of half. Here I'm just showing you the substitution process. Now obviously in the exam you can just put in the calculator and get an answer. But there are method marks given to showing you working out. Just in case you happen to tap the wrong button, get the final answer wrong, if you have your method in place, you're working out in place, you will get the method marks for these. As 4 plus 12 is 16, 16 to the power half, root 16 is 4, and 6 times 4 is 24, minus square root of 4 is 2, 6 times 2 is 12, and 24 minus 12 is 12. So in other words, the area of region R is equal to 12 units squared again. Okay, so the next stage is to work out the area between two curves. So here in the diagram, the top curve is given by y equals f of x, and the bottom curve is given by y equals to g of x. And the area we want to work out is the area between those two curves given by the region R here. Now, if we were to ignore the g of x and only integrate the f of x, it will give you everything below the top curve, including this region here. If you integrate g of x separately, it will give you the area underneath that curve. So therefore, the area of the shaded region here, so the area of R we have to integrate the top curve first to get the area, everything underneath the top curve. So the area of f of x from x equals a to b with respect to x. And we're going to be minusing off this area here, which is given by the integration of g of x with respect to x from x equals a to x equals b. So in order to work out the area between two curves, we work out the area underneath the top curve minus the area underneath the bottom curve, and the resulting area is the area between two curves. So let's move on to the next example. Here we have the top curve given by y equals sine of 2x, and the second curve, the one underneath here, is given by y equals to the sine x multiplied by cos squared x. So we asked to work out the area between those two curves for the x values between 0 and pi by 2. So area between two curves is given by the integration of the top curve, which is sine of x between x equals to 0 and pi by 2, minus the area of the bottom curve, x between 0 and pi by 2. Now, because we are integrating two separate functions within the same bounds, what we're allowed to do is put it into a single integration between 0 and pi by 2 of sine of 2x minus, just going to rewrite the second one as sine of x bracket cos of x cos bracket squared dx. When we now integrate, well, what differentiates into a sine? We know that cos differentiates into a sine, so we can start with cos 2x. If we differentiate cos 2x, we get a minus 2 sine 2x. We don't have a minus 2 there, so adjustment is minus a half. So for the second one, we see that if we differentiate what's inside the bracket, we have the answer sitting on the outside of the bracket. So we know that's going to be the power 1. So we do cos of x to power 1 more, so power 3. But if you differentiate cos cube x, you get 3 at the front. So you get 3 cos squared x multiplied by minus sine x. So in effect, we have a minus 3 at the front. But if you look here, we have just a negative 1 at the front here. So the negative can stay, so we need to get rid of that 3. So we need to multiply it by 1 over 3. So here, this will therefore be 1 over 3, be plus 1 over 3. Close the bracket, and we go from 0 to pi by 2. So the next step is to substitute the bounds in. Just going to take this off now because we have done the integration. So substitute in pi by 2 gives you minus half times cos pi by 2 is equal to cos pi plus 1/3 of cos of pi by 2 plus 1/3 of cos of pi by 2 pi 3. Bracket, subtract, substitute 0 in, so we get minus half times cos of 0 plus 1/3 of cos of 0 pi 3. Bracket. Plug in your calculator. Minus, so minus half plus a third gives you minus 1. Right, so that gives you 2/3. So the area between the two curves is equal to 2/3. Okay, so moving on to our third example. Well, try this question out yourself. So here we have the curve given by the equation 3 over 1 plus the root of 1 plus 4x. It's bounded between the curve, the x-axis, and the lines x equals 0 and x equals 2. So work out the area of region R. Pause the video, and when you're ready, press play and you can check your working out. Okay, so let's go through this now. So the area of region R is given by the integration. Before we do the integration, just set it up to integrate, so between 0 and 2. So here we see that a differentiation of the inside gives you what's on the outside, or a multiple of it, so it's the reverse of the chain rule. So it's the power 1. So we're going to try 1 plus 4x to power 1 more than minus a half is a half. And if you differentiate this, we get a half bracket 1 plus 4x to the power of minus a half times by 4. So in other words, we have 4 times a half, which is 2. Well, we don't want a 2, we want a 3. So we're going to cancel the 2 off by multiplying by a half. and times it by 3. So altogether, our multiplying adjustment is 3 over 2. And we're going between 0 and 2. So substitute the bounds in now. So it'll be 3 over 2 bracket 4 times 2 is 8. 8 plus 1 is 9. So it'll be the root of 9. Subtract 3 over 2 multiplied by 4 times 0, 0, 0 plus 1 to the power half. So here we have the root of 9, which is 3 times 3 is 9 over 2, minus 3 over 2, which is equal to 6 over 2. So the area we should have got is 3.